Hello everyone, and welcome to the implementation of a queue lecture. In this lecture, we're going to build on our previous understanding of queues by implementing our own class of queue. Before we begin implementing our own queue, let's go ahead and review the attributes and methods that this queue class will have. So we're going to have 5 basic methods and attributes. The first one, which is just the queue class, is going to create a new queue that is empty. It won't need any parameters, and it's just going to return an empty queue. The onQueue will take in a new item and put it to the rear of the queue. So it's going to need that item parameter, but it's not going to return anything. It's just going to affect the queue. The dequeue item removes the front item from the queue. It won't need any parameters, and it'll just return the item that it dequeued. The queue is then modified. IsEmpty is going to test to see whether the queue is empty or not. That won't need any parameters and will just return a Boolean value, true or false, depending on whether the queue is empty or not. Then the size method will return the number of items in the queue. It won't need any parameters and it's just going to return an integer. Okay, so those are the basic 5 methods and attributes we're going to do. So let's go ahead and jump to the code. Okay, so here we are at the Jupyter Notebook, so let's go ahead and code this out. We'll first just start by creating our class. And what we're going to do is go ahead and instantiate our class. Just going to take in self. And we'll do the same thing we did for the stat class. We'll just have items equal to an empty list at first. So far we just have an empty queue. Let's go ahead and create our isEmpty. That's going to be the same as what we did for the stack. We're just going to return the Boolean check if that items attribute is equal to an empty list. Then, next up is going to be onQueue or enqueue. So what we're going to do here is say onQueue, takes in self, and then that item. So remember, we're doing a first in, first out principle, just like a regular queue or line as you wait at a cashier or something. So in order to implement this, what we're going to do is take advantage of the insert method that a list can have. And it's going to take 2 arguments. One is the index you want to insert it at, and the other one is the element or item you want to insert. So we're going to have it inserted at index 0, and we're going to put in an item. So as we keep inserting items, we basically push the rest of them up. And then for dequeuing, what we're going to do is not take any arguments there, and we're just going to go ahead and pop off that item. And then finally, for checking the size, what we're going to do is just return the length of self.items. And let's go ahead and make that into the size method. Sorry, I wrote that in a bit of a weird order. Okay, so I ran that. Let's go ahead and mess around with it and make sure everything's working. So we'll create a variable queue, which stands for queue. Let's go ahead and just check right off the bat what its size is. And let's make sure that it's empty. Okay, so that's looking good so far. Let's go ahead and add an item to it. So we'll add 1. And we'll add another item. In this case, we'll say 2. So now what you should be asking yourself is, if I call dequeue, what item should I expect to come out? Well, remember, it's first in, first out principle here. So I should expect the first item I put in, 1. If this was a stack, we would have gotten 2 out. Okay, so go ahead and play around with this. Make sure you understand basically the first in, first out principles here that we've done in our own queue class. And make sure you're actually able to implement this on your own. Okay, with that being said, thanks everyone, and I'll see you at the next lecture.